Hello and welcome to this new lesson in which we are going to write our Python script for the train model, which we already, or which is a follow-up to the face shot script. Now, go ahead to the face recognition and create a new file. The new file will be called train underscore model. Now, let me explain it in few words. The train model is basically a Python script that will take the images from the folder we created using the face shot Python script and convert them into, let's say, zeros and ones into a database. And whenever we want to compare this face, which is Ashraf face, my face, using the images created by the face shot, we will not compare an actual image. We will compare zeros and ones, which is basically the output of the train model Python script. So let's get started. The first step is importing necessary libraries. I'll import them first, then we can talk about them. First, we need to import iModels library, import paths, and we also need to import the face recognition library, and we also need to import the pickle library. We need to import the CV2 library, the OpenCV, and the OS library. Now, most of them are clear, but the pickle library is basically something you need to know. It's not something you must be experienced in, but you need to know that pickle in Python is primarily used in serializing and deserializing a Python object structure. In other words, it's the process of converting a Python object into a byte stream to store it in a file or database system, to maintain program state across sessions, or to transport data over a network. We will basically use it to convert a Python object into a byte stream to store it into the model or the file or the database that we will use for Ashraf, which is the first phase. Now we also have the iModels, which is basically a series of convenience functions to make basic image processing functions such as translation, rotation, resizing, and a lot of other functions. Now let's go ahead with our code and let's start by locating our images in the data set folder. So first print. Now in here we need to print the info, start processing faces, depending on how many faces we have. Now the image paths, which is basically the location where our images are, is basically the data set. So we will create a list of image paths.list underscore images, and we will give it the data set folder name. Now we need to initialize the list of known encodings and known names. So write known encodings equal an empty list, known names equal an empty list as well. Now we need to loop over the image paths. And to loop over these paths, we need to use a for loop. So write for, add to parentheses, I image path in enumerates image paths. This is the for loop structure, which will go over the image paths that we already created here, which is a list of paths inside the dataset. So we need to extract the person name from the image path. So write print. In here, write info, processing image, add 2 curly braces, and after that, close the double quotation. Let's add another one here. Then add dot format I plus 1, comma, and let's proceed here. The length of image paths. That's it. Now, after doing that, we need to take the name. So write name equal image path dot split. Now, let's explain a few things. We have imported something called OS, or operating system. Now, OS, as you can see, has a description here on Visual Studio Code, but basically what you need to know is that the OS module in Python provides functions for interacting with the operating system. OS comes under Python's standard utility modules. This module provides a portable way of using operating system independent function. Now, we will use it here inside the split function, and we can use it easily by simply writing os.path.set. Now, doing this will make sure that we are taking the list name by name, and each name will be stored here so that we can do further processing on the person. Now we need to load the input image and convert it from RGB to DLIB, which is the library. Now we have two ways that are used by OpenCV. We have OpenCV ordering and we have the DLIB ordering. We need to make sure that we are converting the images that are available inside the folder with my name from the OpenCV ordering to the D library ordering. Both of them are RGB. To do this, we can simply write image equal cv2.imRead image path. We will first read the image path. After that, write RGB equal cv2.cvt color, and we will give it the image, and cv2.color RGB, BGR here, to RGB. As you can see, you need to write this. This is a macro and it refers to something in the back end. So color underscore BGR to RGB. If you wrote this, then you are good to go. We need to detect the X and Y coordinates of the bounding boxes corresponding to each face in the input image. And to do that, we can simply create a box. So write boxes equal equal face underscore recognition dot face underscore locations, and in here write RGB, comma, model equal, here write hog. That's it. Now we need to compute the facial embedding for the face. So write encoding equal face underscore recognition dot face underscore encodings, and here write RGB, comma, boxes. Once done, we need to loop over the encodings that we just got. So in here, for encoding. In encodings, we need to add each encoding plus name to our set of known names. And to do that, we can write known encodings dot append encoding. Then known names dot append name. Once done, print info as usual, serializing encodings. Okay, we need to put all of this inside these two double quotation. Now we need to dump the facial encodings plus name to disk. And to do that, we can simply write data equal. In here, we need to write encodings, and we need to add it inside two double quotations. Then we need to write known encodings, comma, then names, known names. So we have two now. Now we need to add double here. That's it. The last step for dumping is f equal open encoding with an s.pickle, and we already mentioned this library. And here write wp. We also need to add this between two double quotations. We also need to write, so f.write pickle.dumps data, and the last step is f.close. That's it. We are done. I know this is a lot to take in. You are not required to memorize all of this or know what each of these lines do, but this is the code to train your model. You basically import the required libraries, then you take the image paths from the dataset, then you create encoding and name, which are basically initializing the list of known encodings and known names. After that, we create a for loop to loop over the image paths. Then we extract the person name from the image path. After that, we load the input image and convert it from the RGB, which is the OpenCV ordering, to dlib ordering, and we did that here. Once we are done with that, we need to detect the x and y coordinates of the bounding box corresponding to each face in the input image. Then we create or compute the facial embedding for the face. Then we loop over the encodings, as you can see here, by adding each encoding plus name to our set of known names and encodings. The last step is, which is basically these lines, dumping the facial encodings plus names to disk so that we can use them by the next script, which is the final facial recognition script. Now in the next lesson, we will test out this code, but that's it for this lesson. Thanks for watching. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson. Now we are ready for our next step, which is basically using the second script to train model. Now, if we went back here to this folder, we will find that hello and welcome to this new lesson. Now we are ready for our next step, which is basically using the second script to train model. Now, if we went back here to this folder, we will find that we have a train model Python script. Now we can open it using the Thonny Python by simply clicking the load, and use train model. Now we need to paste the train model code and simply hit the run. Now, as you can see, we have an error, and as usual, we need to fix any error that we might face while writing the code. And this error is simply a, let's say, sign error, because this should be -2. So it was written incorrectly because of that copying and pasting. Now hit the run button again, and the code will run without any problems. Now, as you can see, it's processing the images, processing image 1, processing image 2, processing image 3, and so on. Now it will keep processing the faces depending on how many faces and how many images there is. And you also need to make sure that you have a clear camera and a good lighting when taking the photos. Now, as you can see, serializing encodings, and here we have the pickle file. Now we are done with the second step, and the only step that is remaining is the third step, which is running the final script for face recognition. After that, we can modify the code and make it open a door when it detects our face. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team.